Suppose you're interested in calculating the following integral. This is basically the integral of px divided by qx dx. The degree of the denominator, degree of your qx, is equal to 5. And it is more than the degree of the numerator. Degree of your numerator is equal to 3. So you don't have to do any long division. What are we going to do? We're going to try to use the partial fraction and simplify this. In applying the method of partial fractions, we try our best to factor out the denominator. Factor the denominator. But the denominator is equal to x times x squared plus 1 to the second power. What do we have here? We have a linear expression, and we have a quadratic expression raised to the second power. And please note that x squared plus 1 cannot be written as x plus 1 times x plus 1. You cannot write it in factor form. So you end up with a linear expression times a quadratic expression that is repeated twice. This is basically the fourth case of the partial fractions. In the fourth case of partial fractions, when you have something like this in general, if you have px divided by qx, and your qx is equal to a linear expression like ax plus b to power r times, let me use a1 and b1, then a sub 2 x squared plus b sub 2 x plus c sub 2 to power k, then you need to break down your partial fractions this way. Px divided by qx can be written as, here you have a1 divided by a1x plus b1 plus a2 divided by a sub 1x plus b1 to the second plus dot 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 a sub r divided by a sub 1x plus b1 to power r. This is for the first part. This is for the part that you have linear expression to the rth power repeated itself. But for the second part that you have a quadratic expression that doesn't have any real solution, you're going to write it as plus, here you have b1x plus c1 divided by a2x squared plus b2x plus c2 plus, you can use other letters if you feel more comfortable, like, I don't know, e1, f1, e1x plus f1 divided by a2x squared plus b2x plus c2 to the second, and you're going to continue this process until you get to the last part, which has power k, right? So plus, for example, a lot of us use I1x plus j1 divided by a2x squared plus b2x plus c2 to power k. So this is the general approach when you have more complicated cases like this. This is basically what we are having here. We have x times x squared plus 1 to the second power, a linear and a quadratic. So let me rewrite this guy down here. So we can take the integral, copy this down, paste. This can be written as the integral of a divided by x plus, well, here you have x squared plus 1 to the second power, so you get two fractions out of it. X squared plus 1 to the second. And here on the numerator, you can write it as like cx plus d. And you can write this guy as ex plus f. And then take the integral with respect to x. So we need to take common denominator. Which is basically x times x squared plus 1 to the second power, and set the numerators equal to each other. So here you have 1 minus x plus 2x squared minus x cubed equals to, well, you have a times x squared plus 1 to the second plus, you have cx, just use parentheses, cx plus d multiplied by x, also multiplied by x squared plus 1 plus, and now you have ex plus f multiplied by the missing factor, which is x. So these must be equal to each other. You can use the shortcut, or you can form system of equations. In order to form system of equations, we have to write this in factored form, in expanded form, because all of these are written in factored form, right? So let us begin, everybody. So 1 minus x plus 2x squared minus x cubed must be equal to, so you have a, and then parentheses, x to the fourth plus 2x squared plus 1 plus, well, here you have a lot of multiplications. You get cx plus d, which becomes cx squared plus dx. So here we have c times x times another x plus dx times x squared plus 1 plus, and here you have ex squared plus fx ex squared plus fx very good. Okay. So 1 minus x plus 2x squared minus x cubed can be written as, here you have a x to the fourth plus 2ax squared plus a plus, can distribute this into parentheses. So you get cx to the fourth plus cx squared plus dx cubed plus dx, and then the rest of them plus ex squared plus f times x. So as you can see on the left-hand side, we don't have any x to the fourth. What's the meaning of that? It means that the combination of a and c must be equal to 0. A plus c is equal to 0 so far. What else do we have? We know that dx cubed is equal to negative x to the third. So d must be equal to negative 1. What else do we see? We have a lot of x squared. So let us use a different color for this. So you have 2a x squared. So far I have a 2a. Then I have cx squared plus c. Then I have ex squared plus e. On the right-hand side, it must be equals to 2. Okay. And then the linear terms. For the linear terms, I have dx. So I have a d and I have a fx plus f must be equals to negative 1. Okay. And I have a must be equals to 1 itself. Okay. A is equal to 1. So since a is equal to 1, c becomes negative 1. I have a, I have c, I can find e. So 2 times 1 minus 1 plus e is equal to 2. You can cancel out 2 and 2. So e becomes 1. D is negative 1. So what's the meaning of that? It means that negative 1 plus f is equal to negative 1, or f is equal to 0. Do I have all the missing pieces? It looks like it. So I'm going to copy this guy down and substitute everything. A lot of algebra involved. You're almost done. So you have a is 1. So just substitute 1. What is your c? So we are done with a. What is my c? C is negative 1. I'm going to copy this guy down here. Negative x. And what is d? D is equal to negative 1 as well. So you get minus 1. What is e? E is equal to 1 and f is equal to 0. So I can get rid of this portion. I have just x. Beautiful. Almost done, everybody. Now we need to take the integral of each piece separately. This integral is basically ln of absolute value of x. So this is your integral here. But for the integral here, I can divide this up into 2 pieces. I have negative integral of x dx divided by x squared plus 1 minus the integral of dx divided by x squared plus 1. So again, I took the middle integral and divided that up into 2 integrals. And the last integral is plus the integral of x dx divided by x squared plus 1 to the 2nd power. So for this integral here, I'm going to take u to be x squared plus 1. Du is 2x dx. So 2.5. One by one, I'm trying to find these integrals. Minus a half ln of absolute value of x squared plus 1. This integral is inverse tangent of x and for the integral at the end, I'm going to take u to be x squared plus 1. Du is 2x dx. So multiply by 2, divide by 2. It becomes the integral of du divided by u squared. So it is negative 1 divided by 2 times x squared plus 1 plus constant of integration. Ooh, a lot of work. We used partial fractions. we found the integral, and inside the process, we used inverse tangent more u sub to calculate the integral. So from top down, let us go over the summary here. So here I have the integral of 1 minus x plus 2x squared minus x cubed divided by x times x squared plus 1 to the second. The degree of the denominator is more than the degree of the numerator, so you basically no need to use any long division. Since you can break down the denominator into x squared plus 1 times x squared plus 1, you have a repeated quadratic expression. So since you have a repeated quadratic expression, it needs to be broken down into two partial fractions. For the first one, which is just linear, we use a divided by x, but for the rest of them, we need some linear expressions on the numerator. Our goal is to find these coefficients and constants by taking the common denominator and forming a system of equations to help us find the values for a, c, d, e, and f. Again, for these letters, you are free to choose any letter that you like. You can use A1, B1, C1, D1, anything that you like. So we did a lot of algebra. We wrote this in expanded form. We solved for A and C and D and E and F. And we noted that F is equal to 0. So our integral is broken down into other integrals because, for example, negative x minus 1 divided by x squared plus 1 can be broken down into two integrals. One of them is inverse tangent. The other one is u-substitution that we are feeling comfortable working with. So that's how we calculated this integral using partial fractions and u-sub.